there's some small analysis that I did on these piles. You see, this pier support system, there are two scenarios, actually four. You have a pile cap. If I can just show you from here, you have a pile cap with pier with a pile cap flashing with the high water level. That is scenario 1. Then this is water depth. Then the second stratification is your loose soil susceptible to scour, and this yellowish is the medium dense soil, and the last one is dense soil. Of course, if you do detailed geotech, you should be able to find the different SPT values, the density of the soil, and then when you encounter rock, the RQD, the UCS values, you get it all the way down. But this analysis which I did was trying to look at, if I choose this support system and compare with this second one, which to the right, which has the pile cap at the base or at the riverbed. So that means my height at the onset is from this point at the riverbed all the way to the top. But it is a breast midway or at the high water table or water level. Then this one has a pile moving all the way from the soffit of the deck all the way to this one. So it's more like slender, very long, but also there's a bracing with a collar beam. And the piles are all here. So all these spring constant, the simulated contact, are exactly embedded into the rock, into the soil. While here you have a portion of pile in water. By the way, this pile length about 24 meters. So even here was about 24. So it will slightly be slightly up here, but because the rock quality for this with this elevation, it was bearing in the rock quality less qualified than down here. So I had to now extend this rock level up here. So there's already a bit of extra. This become longer than when it is here, but here becomes also longer when it is at this point. So pile cap at this point, the height of the column is shorter than when the pile cap is at the riverbed. So this is exactly what I was trying to look at. So when scoring happen, 20 years, 15 years, 50 years, when scoring happen, it exposes this support system to instability, slenderness, and therefore a designer also need to cross-check. So when you come down here, you see now here there's no water at this point. Water now is now the score. This is the scoring. Well, once it's scored, that means the water depth actually move to that point. That is the water depth. So water depth now goes like twice. Oh yeah, depending on the score depth. The score depth has to be calculated. You guys, I know you have the formula. I'm not going to dwell into that now, but I wanted to see the implication. So at the beginning you have like maybe say X or H1. After 20 years or 25 or 30, depending on the soil particle and the treatment around here, the score can go twice or thrice or 1.5 times the water depth, depending on the soil parameter that is If it is clay, which a bit stiff and it holds water in a way, maybe if it is a soil, silty sand, you know, very particles can actually go. So basically, you may find the rate of scoring will depend on the soil type and the treatment around. So now, 50 years or 34 years or 40 years, you find your pile cap up here, water fluctuates within there, but there's already additional depth of water. That means the water flowing moves here, and then this time now this Pier scenario with pile cap at the riverbed now has already also some score depth, which now give also an extra depth up here. Of course, still the same, but the bracing system differ. Here you have two bracings, while here is only one bracing, and also the score has gone slightly down. So these become the pile. So if I had not extended this and it was the same with about here, that would mean if the pile had remained like that here and there, that would mean now our pile would become unstable, and therefore there would be a problem. So that is why I say no, it's important to first extend it. Then you do analysis to check. A lot of things you need to check. There is also liquefaction. This soil here, if it is purely soil and an earthquake happens, they always talk of this liquefiable, this porridge-like state of soil. That happens. Therefore, leaves us to have effective depth with a bit of good rock, or even if it is fair to good rock to anchor your structure up to sound, so that you avoid the soil condition which changes to porridge-like during earthquake or tremor. So that definitely would also disqualify and also create a bit of instability condition. So normally it's avoided in your analysis. So this is the situation now. Score has happened. So someone need to do analysis. You need the loading remain the same. You need to reconfigure your soil structure interaction. No more stiffness simulation, I think, in this zone. You have to bring it down to where the soil started going down, and therefore there's going to be a change in the response by this support system. These are two different scenarios. Pile water depth increases, pile cap at the still floating, but the depth has increased twice h. This one has gone because for it with the pile cap it is just also gone, but not twice, depending on the amount of score. So when you do the analysis, I observed that for this one, these are the upper one, these two. This is before scoring, this is after scoring. This is before scoring, this is after scoring. So you find actually that the piles with the pile cap floating tend to have implication on the middle third of pile length downward, while the case where pile cap is at the riverbed, it appears that moment of this long, very high pier columns tend to be very, very high on the base than here. And yet here, because of pile cap, it transfers this load and the piles start experiencing very heavy actions. So you can actually look at this. Then down, this is how you can actually look at when you remove that, then it is more. So you can see the behavior. Same loading condition, but different placement. This is at the riverbed. This is at the high water table. No scoring. That is at the commissioning. After scoring, you can see. Now there is then you can see. So you will have to know what happened. Then later on, when you look at this, there is also what we call critical length of the pile. With the critical length of the pile, I hope I had it here. I would have actually looked at it. Yeah, the depth beyond which additional pile length does not significantly increase capacity, because subfriction has already mobilized and end-bearing governs. So control factors are soil, rock stratification, transition from weak to strong rock, liquefaction zone, for this case upper 9 to 10 meters they were ignored, pile diameter, larger pile mobilize friction faster, and then group effect, spacing, and pressure back overlapping. These are things we could actually check. So what I wanted to look at is the critical length. So if it is a 1.2 diameter, then you find that it's about 13 to 17, which is approximately 18. If it's about 1.5, it's about 16 or 17. So when you come back here and you have a look here, you'll find that actually your moment, what would differ is the shear, the axial load. Axial load will go further than this one. So it's always not good to say, okay, since moment ends here, we cut it. No, because you have three forces here. Actually, you have the bending moment along here, then you have the shear force, then you have the axial. So these are bending moment. Definitely, if you what happened here because of lateral load and then fixity is at this point down here, because this is water, it is here that the pile cap considered as rigid, but here it is we cannot consider as rigid because it's already up. The depth is from here up to up there. That's why the behavior here, you need to be mindful as much as you also try to do more here, but there's the lower middle third tend to be more stressed than any part of the pile. So basically that's something I try to check quickly and have a look at using Midas, model it, then you do your spring constant, and then you get the subgrade reactions, the X, Y, or the H, the horizontal subgrade reactions. There are different narratives which you can use to calculate that, because from the software you are able to define. So these are the things that are here. And if I could quickly look at the axial load, axial load will definitely give me something different that I wanted maybe to look at. So someone should not rush so quickly to, so you can actually see that actually, you see these two are on the, so when you look at the axial load for this area, this is the one that has already been affected by Scour. You see it is more, it tends to get more, it is a higher value when compared with the same level and when it was not there was no Scour. So you can look at this parameter you get, whereas high moment here exists here and here, the forces on the pile tend to be fairly okay. This, because this pile also, you need to also take note that there are two things I learned handling pile. One, pile foundation. You need to know whether it is a rigid pile or whether it is a flexible pile or cylinder. So cylinder pile or flexible pile, normally you use friction, while rigid is when you can use air. But also, in a way, they can still, especially for cylinder, can combine both friction, and so we modeled, and then we didn't put any support here for N, so that we simulate, so you can see this. And that is why when you look at the shear force, basically for when you look at this and that, so these are the shear force happening. So you can see for this, because it is already up, tend to be slightly lower than when this is fixed and it's at the riverbed. And then for the axle, you can see that's how the axle would apply, and this is how the moment would apply. So there's a fixity here. They also partly there, but it's more it's redistributed kind of along, because it's really floating up and there's nothing. All the thing is being held at the lower point here. If you view on site, this is the riverbed, and that is where the pile cap is. So basically, that is a simple analysis. Of course, it is detailed. Of course, now these are collar beams. They are subjected to loads. If you do. We also have vibration. I checked against earthquake, and also realized that actually with earthquake, you'll find actually was very interesting, and I think we need we need some reading here. There are 4 cases here. This one here is the pile cap is in water, well, now flashing with the high water level, while this one pile caps are riverbed. Then this is the pile cap is also water, but the score has already happened, and here score has happened. Now you find that with only mode 1, this is already deforming. That is something very interesting. Then when I go to mode 2, instead of all of them, that is the first one, then mode 2 brings, so you find actually these two they are higher than, they are more slender than this, because this pile cap act as a bracer or bracers. So these two already excited with this C2 mode. Then the third mode, now I see something happening, and then it moves to that, because this one already scored. After you can see where it is. This is the score is up to somewhere down here, so it exposes this higher, longer than this one here. Then the last one is now when you view the mode of vibration, and it happens on this one. This is something I noticed. Why I was asking, why is it that they are not? So I'm going to get and try to look at it in detail to see the vibration mode earthquake effect on the different height and then configuration of the bracing system, so that we are able to understand. That is something that I tried to look at, but the rest now I didn't bother too much, because it's the whole vibration mode keep affecting start with this, then move to this, then go to that, then come. So depending on the sensitivity, so which one is vulnerable. So that means in design, this element could be the one experiencing worst case, that if you design for it well, shouldn't. But when we check the more moment, we realize that this one get more affected. You need more shear reinforcement at the pile cap than any of this. This one here. So that is something we notice, and so it's a very interesting thing that I brought it forward, because this session is where we do a bit of brainstorming to understand few things, and then you carry on with what you think is better. And if you have so these are some of the behavior. So these are the 2 columns, and then these are the pile. These are pile. You can see the way pile fails here, because we're now subjected to, I think, earthquake effect. And then, so if you look at on the earthquake, like in the X direction, what would be the behavior of this pile cap? That is something that you would have to look at. And then if you do Y, what would happen? Okay, Y you can see. Then Z would be something also similar, but I think so this is for Z direction and the Y direction. Then so basically that is something you do. You can also check the stresses which your pile cap can be subjected to. And then so this is the stresses that the pile cap can actually get subjected to, the different scenarios. So you can see this one, because this one, if you look at these two, this is the one with this one is the one with pile cap flashing the high water table. This is the scenario 2 with pile cap at the riverbed. So because you saw this case here, there's a high force down here, moment force and shear force at the base. So that's how you find that these tend to get more of this part. Okay, let me just reduce that. So now this is now how the whole thing is. A very interesting coloring, you guys can enjoy. So there's already an element here with a very high. So if I could actually look at the cutting section, I think it is on this one. Okay, this is different, but this is a cutting section. But okay, so if I can now only trim this so that we can look at how the whole thing behaves, I will look at it this way, and then that's how the moment is. And then I look at it in this direction. I have cut, and if I look at that, so I'm cutting this section all the way that direction, the longer way, which is about 15-12 meters. These are pile location. You can see punching can happen here. So these forces you can see now, these are at a very high. So I think the issue here is, you see, if I change, you can see you can change you can do a reverse look at what is, but there's a reason why it's also facing down. I think because this load here, it is very, very high. You can see the loading along these these two pier column. These are the piles. So that is something that I was trying to look at. It's an assessment to just see the implication of using piles at riverbed and piles at higher water level. Then I have learned something. Of course, I know there are issues to do with constructability, use of seat piles. The one down, you need to do seat pile. If the depth exceeds 5, maybe you need now to do double seat piling and see. But you have to design and calculate. Then you do water, you fill the pile cap with maybe gravel and what, so that you do proper centering and drilling properly in a way that is more safe and correct. And while this one, I saw a simple YouTube. You guys can visit YouTube, type and look for that. You get similar one. How guys do? They use steel casing all the way down. You do the same steel jetty, come and do, and then you do, and then you get down. Basically, so that is, I think, the assessment that you can actually check the difference between the two. Basically, just as brief as that. Yeah. So that is, you can look at this water depth. So we'll just do so you have to be mindful when the water level is different. So when the pile cap is hanging here, is a different bracing system when it is here and here. This acts like two, but because these columns are very deep now, the effect of bending when you fix here and then this is moving, definitely is higher than when you apply a 0.11 kilonewton load here and here. Definitely here the lever arm here is higher, is longer than the lever arm. Here it breaks that moment, so it become a bit less in a way. But so it's a very interesting thing that you guys need to look at. You can see this by yourself, but it transfers the effect here, which was supposed to have been more into your pile system. So even your pile system, you need to be mindful of. Yeah. So I think that is something that I did. I mind map you guys, brain teaser, and then get into your books. Quite good. Thank you.